Alright, so here's the homework from last night, and I want to jump in and solve pretty much every problem. So we have a 9 kilogram mass being pushed across a floor with a coefficient of friction. And let's go ahead and draw the free body diagram. So we have the normal force going up, we have the weight or the force of gravity pointing downwards. We have the boy pushing, we'll call that force F. You can call it FP for force of pushing if you want. And then we have the friction opposing the pushing force. So we want to know the force of friction acting on the box. So to get that, we know that friction is going to be mu times n. Again, friction is fun. Now, because the normal and the gravity balance, we know that the normal actually equals, I should say the normal and the downward force of gravity balance. That means they are equal. So in this particular problem, the normal force happens to be equal to 9 times 9.8. Again, the mass times the gravitational strength. And we're getting 77.9 newtons of force. And so to go ahead and get the friction force, that's going to be 0.7 times 77.9. And when we simplify that number, we're going to end up getting 61.74 newtons. Now, it says the box is sliding at constant velocity. Again, that indicates that the pushing force and the friction force are completely balanced. If they weren't, the box would either be speeding up or slowing down. So this tells us the force of pushing is also 61.74 newtons. Alright, so what I want to actually do here is go ahead and give you the answer, and I want you to check your answer with mine. What I end up getting from you is 0.54. So you should definitely see if you can check that out. Now, meaning see if it makes sense to you, and if not, come and see me. So for number 3, if the boy from number 2 continues to push on a smooth sidewalk, smooth means no friction. And if there's no friction and we're pushing something, that means it's going to speed up. Now, if he stops pushing completely on this surface, then we're kind of in the dry ice lab scenario. So what's going to happen is it will continue in a straight line at constant speed. And finally, how hard would he have to push to keep the toy moving at a constant speed if the coefficient of friction between the tires and the smooth sidewalk is 0.1? So let's remember the mass is 15 kilograms. And we know that mu is 0.1. So I urge you to draw a free body diagram and solve. And when you do that, you will actually end up getting the force of pushing is equal to 14.7 newtons. So this is page 1, and we'll take a look at page 2 of the homework in the next video.